Alright guys, so let's move ahead and talk about caching. So we have this simulation here, right? Now it's time to really cache it so we can do some render. To set that up, we need to create a geometry, right? And I'm gonna call this guy SmokeSim cache. And inside of it, I'm gonna delete that file node. I need to actually drop down a .io .io for our input from the simulation. The .network will be our smoke simulation, and the .node will be our smoke object right here. Now we have to change the preset to smoke to have all the field here. We don't really need temperature. I'm gonna change that to rest 2. And because of that, I have to go ahead and set up rest fields. Okay, so for now we don't have any rest field, as you can see here on the object. Actually, nothing there. Let's go back a few frames to the cached ones. Not really seeing anything. All right, so oops, where are we? Actually, yeah, I didn't see anything, so it's a little weird. Let's go back and simulate it again. Let's take a look. Not really seeing anything. I'm gonna redo the caching. Go to the SmokeSim and reset simulation so that it's empty now. Let's go back to frame 1, reset it, and then I want to go back and do the simulation one more time just to make sure that we have the field we need. Stop the simulation. Let's take a look. Yeah, we have all those field now. So we have density, right? Velocity. That's what we have here on the preset. We have density right here, velocity, but we are missing. Yeah, we're missing the rest and rest 2. Okay, so I'm gonna go ahead and set those guys up back to my simulation. Here, to turn on rest field, you have to go to the initial data on the smoke object and check out add a rest field. That's one thing, and it's gonna take a while to recalculate. We probably need to restart everything to see that. Let's go back to Parallel Solver 2 and also go to Advanced. And also go to rest field and turn on enable rest to truly enable the rest field calculation. You have to have both of those things turned on. Okay, let's see. We probably need to go back to frame 1 and go play it again. And let's stop it right here and take a look. Just want to check if we have all the things we need. We have rest 2, rest, right? We have density and velocity. That's everything we need, and that's actually everything we're capturing here too in the .io. Right, density, velocity, rest, and rest 2. So I'm gonna go ahead and change the geometry file name to just $ operating string, and there I'm gonna call this guy smoke cache. Okay, so it's gonna cache the smoke. The name will be smoke cache dot name padding and or frame number and then the extension. So that should be the basic setup of our simulation or of our caching. But depending on how much detail you want to go for, you can probably enhance the simulation time, because this is going to take hours, even days to simulate. If you just use the default setting and everything that you especially the two things that we haven't even constrained in the settings that we could enhance, which is the smoke object range and also the division size. So let's talk about division size. If you want to determine like your division size, you can actually let me turn on the rigidity selection so we can see this guy and the cache result. And let's actually take a look at the render. I'm gonna go ahead and change my render camera to the render camera and render it here. Now what you want to be able to try to, you know, see is that the quality you're getting from the render, right? Is it good enough for your simulation? Now that's greatly based on the distance from the camera to the simulation. If it is far away like this, right, you probably don't need a lot of detail because you wouldn't even see them anyways. One of the good way to judge that, if you as you click here to, oops, actually here, the lower one here, the lower bar here, you do a snapshot after your first render, and you go ahead and toggle or tweak the simulation quality. Like how about 0.5? Let me stop the rendering here. So instead of 0.03, I'm gonna change that to 0.05, right? And let's do one more simulation to frame 9. And what I want to compare is that, do I really see any different when I lower down the quality in the render? So I'm gonna go ahead and go to frame 9, and I'm gonna render it one more time. I'm gonna compare this one with the old one and see if I do lose any important detail. If I'm not gonna see any big difference, then I'm gonna say I probably need to go just with 0.05 instead of 0.03. Now I can see I'm losing some fine detail there, right, on some of the parts, but I don't think they're really fierce in this way, in this case. So I'm gonna say I'm gonna keep with 0.05 instead of 0.03 because it's really gonna be super slow when you actually simulate it. But depending on how much detail you want to have, you can keep as 0.03. Okay. Another thing you wanted to be aware of is your limitation of the simulation bound. The limitation of the simulation boundary can be defined by this guy here. If you go here and use clamp to maximum, and it's gonna follow what the size of this guy. I don't want that, so I'm gonna turn that out. What I really want is define a size that I know that is not supposed to be bigger than that. So one of the ways I can go for is, again, go to my camera so I can see the background. I'm gonna go here and then use this guy to figure out the size. So I'm starting with 2.5 here. I'm gonna remember this number. I'm gonna change that to something bigger. Let's try 15 and see how big it is. So one thing I do know is that I don't really need the simulation to go beyond the frame range, right? The top of the frame, the bottom of the frame. So if I go ahead and toggle that to 15, let's go back to frame 1 so we can really see it. This bigger box here, that's actually the box, right? Now I can see 15 is probably okay, but just to be safe, I'm gonna go for 20 so that I can guarantee that that's the maximum range I probably will ever need. Okay, maybe even smaller than that. Let's try maybe 18, because you can see this box is already bigger than the actual frame. So 18 should be good. Okay, so I'm gonna say 18, and here I'm gonna copy this value actually and just go back to 2.5. That's where I started. Maybe even 4 just to be safe. And I'm gonna go back to the fluid dynamic. I'm gonna tell it to clamp to maximum, use manual way. Right, the size will be 18, which is what I defined. The center will be the same as the center of here. I'm gonna copy parameter right here and go to here and paste relative reference. So this is gonna try to constrain or limit this dynamically updating box to this specific limit. From the center here to the size of 18, which is the box we were trying to figure out earlier. So now it will actually go no bigger than that, especially for the top ones, right? When they get too high, we don't really need to see them, so we're just gonna cut them out. Alright, so that's gonna be it for the enhancement of the simulation time. Again, those steps are really important. They can even a little bit of enhancement, like the division size and dynamic fluid dynamic range, can enhance the simulation time quite a bit. Oftentimes it's in a matter of a not a linear but a exponential degree, 8 times faster or things like that. So you probably really wanted to try to, you know, really determine the numbers to exactly the minimum you need. All right, so, or the quality to the minimum you need. So we're gonna say this is probably good, but I may need to go back and toggle things if I don't see any, if I see some artifact like clipping. I'm not sure yet, so I'm gonna go ahead and do the cache. Okay, so I'm gonna check on save to file and save to disk. I'm gonna let it run, and when it's done, then we can come back and talk about the result. Okay, thanks for watching. See you next time.